Good morning, good afternoon, and good evening, depending on where in the world you're joining us from. Welcome to our expert panel, Driving Next-Gen AI Applications with AWS and Astronomer, brought to you by our friends at Astronomer. I'm Brian Mink, co-founder and president of Data Science Connect, DSC, the world's largest data and AI community. Today, we're excited to welcome hundreds of attendees from all over the world to discuss how AI is shaping modern organizations' decision-making, helping drive critical business decisions, and support customers and stakeholders. Today, we'll discuss the unique opportunities and challenges around adopting and deploying Gen AI at scale. Our speakers will demonstrate real-world applications, including conversational AI, code generation, automated troubleshooting, and practical examples of model deployment and operational LLMs. And you'll learn top strategies to harness the potential of AI and natural language processing to drive innovation in your organization. We're honored to hear from a distinguished group of speakers today. Stephen Hillian, SVP of Data and AI at Astronomer, David Shu, Machine Learning Engineer at Astronomer, and Parnav Basak, Solutions Architect at Amazon Web Services. Before we begin, a few housekeeping items. First, to make this feel a little more in person, we suggest you add a profile to your photo to your profile and include your bio, LinkedIn profile, and other information you'd want your fellow attendees to see. Next, please take advantage of the Q&A and chat features throughout the talk. We're dedicating a portion at the end to Q&A, so be sure to upvote the questions you'd like the presenters to address. If you're wondering where your organization stands compared to others in your AI journey, check out the poll questions on the right sidebar. And finally, to learn more about how to accelerate AI application development with Airflow, check out the calls to action below throughout the webinar. Now, without further ado, I'll turn it over to Stephen.
Great, thank you, Brian. I'm delighted to be here with two folks who really are on the front lines of generative AI to talk about some real-world projects that they've been helping customers of AWS and Astronomer with in terms of implementing production-ready generative AI applications. And in one case, actually helping to build those and develop those. And David will talk about some of the challenges that he's faced and how our platforms have helped him out. So it's going to be very interesting, I think, to hear from these folks and learn from some real practitioners who have seen generative AI in action. Let me briefly introduce my company, Astronomer, also David's. I like to think of us as the data delivery company, if you like, the FedEx of data. We're here to deliver data in the form of data sets and reports and predictive models and generative AI applications using Airflow as our foundation. And Airflow is really going to be the main star of this presentation. So let me explain a little bit about that. First of all, for folks who aren't familiar with Airflow, let me just start by stating the obvious, which is data pipelines really power industry and business these days. Every dashboard that's delivered to your executives, every application that's built with generative AI, every data set that's produced through some ETL process, every model, and so on and so on. All of that is powered by complex, interdependent data pipelines. And some years ago, Airbnb created an open source project, Airflow, it's now part of Apache, to handle the management of those data pipelines at scale. Everything from small teams who are developing ETL and SQL against cloud databases, all the way through to large companies, the likes of Lyft and Walmart and FanDuel and so on, who are generating predictive applications and insights through thousands and thousands of data pipelines, all managed centrally through Airflow. Airflow has become wildly popular. It's now arguably one of the most successful open source projects in history on the Apache Foundation. This slide gets out of date every day almost. I think we're up to almost 30 million monthly downloads of Airflow. It's a very popular project. Astronomer is very proud to be a driving force behind Apache Airflow. We help to product manage and drive a lot of those releases. We're very active on the PMC. We contribute about half of the code. And many of the folks who are on the call who are familiar with Airflow and maybe been certified have been certified through the academy that we've created, over 30,000 people globally certified thanks to the efforts of the Astronomer education team. Airflow was initially created really as a platform for data engineers doing data pipelines with Python, as well as frameworks like Spark and SQL and so on. But rapidly, it sort of went downstream to dependent organizations, including the folks who are dependent on those data sets, including machine learning and ML ops teams. And there's a good reason for that. I mean, the obvious is that Airflow is built by and for Python engineers. So it's written in the lingua franca of the data scientist. It's also extensible, so you can build integrations to your standard machine learning libraries. And also there's a registry that Astronomer provides, which shows integrations with hundreds of tools from the data science and the data engineering toolkit. There's a notebook interface that Astronomer has created that allows you to author DAGs easily in a framework that's familiar to data scientists. And we have the ability to have different pluggable, scalable compute that handles both very large workloads and the ability to scale down to zero to save costs. All of those things are important, but perhaps the thing I would highlight is this notion of day two ops. It's all very well to build prototypes, whether that's of pipelines or predictive models. But what's important is to get those into production and have those run lights out in a reliable way, in a way that can be observed, that's compliant with regulatory processes. And then when things go wrong, as they rarely do with Airflow, but sometimes you do need to do troubleshooting, you need to have visibility. So the observability aspects as well as lineage of data sets is a key part of that. And so Airflow has really become a place where data engineers and machine learning engineers meet to share data and share pipelines and work collaboratively. And I would then like to point out, of course, that those integrations that I was talking about earlier very much apply in the world of generative AI. So in the last year or so, we've built in the Airflow community and at Astronomer integrations to a wide variety of different platforms, but in particular, LLM and generative AI services like OpenAI and Cohere, vector databases like Weaviate and Pinecone, and so on. So again, the entire modern data stack is pretty well represented in the library of integrations that Airflow supports, making it easy to get up and running to operationalize your pipelines. Okay, I want to hand over to Parnab now. He's going to talk a little bit about some of the activity he's seen around the AWS platform and its applications to generative AI. So over to you, Parnab.
Thank you, Stephen. So I'm Parnab Basak, and I am a solutions architect working for the worldwide public sector. And in this role, I help out companies of all shapes and sizes because at AWS, we help out all companies innovate, whether it is on AI or otherwise. And as such, what we are looking at is the potential of using generative AI on AWS. We have a set of tools and services which we are going to go talk about as we go down the line that makes really easy for you to build your own foundation models or even take a serverless approach in which you do not have to worry about the underlying servers to be able to use those foundational models for your own needs. But if you're also looking for applications or tool sets to go use generative AI to as a coding assistant, you can also have that flexibility too. And finally, as we are planned to democratize generative AI for one and for all, we look forward to those deeply integrated services that are flexible to build that you might be doing working for your workloads next. Moving on to the next slide, what we also are looking at is the AWS generative AI stack. Let's start from all the way in the bottom where we have infrastructures to go train and build your inferences on. That includes GPUs, that includes our custom-made Trainium processors. It also includes your EC2 capacity blocks, our Nitro Enclave processors, and our neural network technology as well. You can also look at Amazon SageMaker as a service to go use generative AI. So if you're looking for open source models to integrate with in your applications, Amazon SageMaker and Amazon SageMaker Jumpstart are a great options to start with. In the next step, just right above it, there is a tools to build with large language models and other foundation models. We have last year released Amazon Bedrock as a service. Again, it's a serverless service that allows you to integrate multiple large language models, starting from our Amazon own title model, Llama, Cohere, Anthropic, etc. It also provides you with responsible AI features with Amazon Bedrock guardrails. We also have released agents for you to integrate multiple different systems, and you can go ahead and create customized models out of these available models using Amazon Bedrock. And the final step up there is the applications that leverage large language models to be able to do that. We also went globally live with Amazon Q for Business this year. So Amazon Q for Business helps you quickly integrate with your own data sets to create the Q&A kind of a experience that you might be looking for. If you're looking to go use Amazon Q for Developer, you can definitely do so. These are pluggable applications that you can run on your own ID that helps you with your coding assistant needs. Further, within our tooling and dashboards, we have Amazon Q in QuickSight and Amazon Q in Connect. So these are our dashboarding and tooling services wherein generative AI is built in right out of the box. As we move on to the next slide, we're going to talk about the most popular use case that we are seeing across the verticals in industry. And I have kind of broken this down into four categories here. So the first and foremost is to enhance customer experience, where we're looking at chatbots, virtual assistants to ease out the end-to-end customer interaction and thereby automate much of those processes. We're also looking at boosting employee productivity by those code generation content creation tools that easily, with a few sets of instructions, can create amazing results for you. Finally, in the creativity and content creation space, we are looking at things like 3D modeling with instructions. We are also looking at product design and text and image generations for marketing purposes as well that are great game changers for customers who are looking for those. Finally, in the improving the business operations vertical, we are looking at predictive maintenance. We're also looking at quality control and fraud detection automatically to generative AI because they have already been trained on similar kind of data before. As we move to the next slide, we will talk about some real world use cases that we have been supporting our customers on, and they have been using Airflow primarily as their orchestration needs. So let me quickly start with a healthcare customer that we had. So this is a healthcare customer based out of Japan, wherein they are looking to use AWS and the generative AI capabilities there to generate discharge summaries, capture patients' treatment history, and diagnose during the hospital stay so that it reduces the time as they are discharged out of the hospitals and they know have exact set of information versus the pages and pages of doctor notes that they might typically have received. The second use case is on a retail example, wherein a solution powered by our contact center solution helps address complex and costly issues faced by businesses, and that enhances the customer experience and reduces the churn there. Again, Airflow has been a predominant orchestrator in being able to do this at scale across different sets of data. Finally, in the education space, an online course provider based out of India helps out the students by summarizing lecture notes, personalizing the questions that they might have for to evaluate their assessment and understanding of a certain topic, and thereby are helping improve the educator productivity and student engagement as such. So these are just some few examples there. As we go into the next, we have categorized this users of generative AI into broadly three types based on the user skills and the consumption model of generative AI. On the far right, you would see the consumers. So these consumers are people that are getting into the generative AI space, probably experimenting first up and trying to figure out if generative AI can truly be used in its very easiest form. So they are looking at an available large language model that is already available, and then using prompt engineering or instructions to get results out of it. So for this kind of profiles, they do not have necessary machine learning expertise. Okay, and the primary focus point is providing the prompts or modified instructions and getting data output. As we move to the left, there are use cases where users are looking to more advanced features, wherein they are training an existing available large language model with their own datasets to be more focused responses. So these engineers are taking the information that is already there, augmenting the information in different other techniques, and these engineers have a appetite and a skill for end-to-end machine learning expertise using Apache Airflow to that matter, and then being able to also augment that with advanced prompts in this case. And all the way to the left are the providers. So the providers are the generators of new large language models. Think of this as the Coheres, the Mistrals. Even we at Amazon also create new models as well, release them. For this kind of engineers, a deep understanding of machine learning, natural language processing, able to go and understand partition data, etc., is required. But across this, if you see primarily, you would end up looking at this pyramidal structure, wherein you start off with the easiest, which is the prompt engineering using existing large language model. Then you can do for as you grow up, if your needs are satisfied, you further want to go fine tune it, then probably you're looking at a context engineering using retrieval augmented generation patterns, which we'll talk about next. And then as we go further down, you'll probably end up creating a fine tuning model, or if none of these suffice your needs, you probably are looking to train your own large language model and either privately use it or publicly make it available. So as you go up the pyramid there, you're gradually getting it from easier to a more complex domain of architecture, and you need some repetition, you need a lot of experimentation, and or task orchestration or workflow orchestration is crucial and pivotal there. Moving to the next slide, we will look at how we can use the features of large language models along with Airflow for profiles for model consumers. So if you are just taking the existing model and trying to use it in its native format, you're probably looking at a couple of options here. First, you might be looking at what does model evaluation looks like. What I mean by this is you're probably looking at, does this model suffice my needs, or does a different model that is available would be a better fit there? So you might be taking a number of models options here, providing the same set of prompts for to each of those, getting the outputs, evaluating those outputs, maybe based on some human intellect, selecting the best model that might fit your use case there. On the contrary, you might be also be looking at prompt evaluation, wherein you might be taking one single model and trying to evaluate multiple types of prompts to see what makes the most sense, what is more useful and consumable, and fits your business model there. And finally, if I've already evaluated the model, find out what the prompt is the best, probably you are looking at batch inferencing those, wherein you are taking all your existing data sets, running through a pipeline powered by Apache Airflow, and then calling the large language model with that prompt to get the data and store it at a certain place in there. So this is a typical example for model consumer. So the more fine-tuned model consumers are probably there in the next slide, which Stephen is going to go change, and that's called the retrieval augmented generation, wherein we are supplying the large language models with more domain-specific information on the fly so that we can get more factual summarization out of it. So if you see in this chart from left to right, you have your existing data platform. You're using Apache Airflow and ingesting those data into something that we call a vector databases. And then with using that vector database and the power of large language model, using the user input provided, you are creating a more specific answer based on your own data sets for the general versus the general information available in a publicly trained data model that the large language model essentially is. So herein, Airflow bridges the gap between your existing data platform and the available open source large language model to that matter through our orchestrated set of tasks. As we move to the next slide, you will also realize that that is one piece of it. There are also fine tuners that we were talking of. And as a fine tuner, you might be looking at data labeling or categorization of your own data sets, either through a human in the loop process or through your sophisticated data orchestration tools. Then creating that fine tuned model based on a number of different techniques for customizing it with different set of domain data, weights, etc. And then finally deploying that model either as an open source version or for within your own private repositories for consumption. You are using prompt engineering based on your needs and patterns, and then finally monitoring this at monitoring the performance of the models to understand how is the model performing. And you are probably doing this in a repeated scale, iterating over this. And for such use cases, Apache Airflow has constructs to enable you to go do that for a number of iterations to make your model more, uh, more intelligent and appropriate. As we move into the next slide, you will also look at frequent fine tuning being an important piece there. So with a one-time tuning, you might be able to build an initial model, but that doesn't get better over time. You might be wanting to capture real-time user inputs and then doing a frequent retraining of this model, again, powered by Apache Airflow, to make this model more intelligent. Some good examples definitely does make your model more intelligent and better over time. So you might want to also filter out examples that are not appropriate and can be done at scale for longer periods of time. As we move to the next slide, you would also look and realize that there are also providers of models that are using Apache Airflow to create those large language models. But again, creating a large language model is not a very trivial task. You are looking at a massive data labeling job upfront, and you're probably looking at weeks and months of training of that data, and finally deploying the model once you have confidence that your model is uh, doing as you intended it to be. There are also leaderboards that can help create where you are positioned in the model based on other users and consumptions or consumers of your model, and that helps create those performance metrics that may be the biggest differentiator. As we look into the next slide, this is what deep down analysis of creating this model looks like. Again, as I said, you start with data preparation. You're taking the pre-processing code, and there you're training the data to create a model build. You are also understanding what are the different tasks and matrices of the model that is out there through your model evaluation phase. Then you are selecting one of those models that you have created. Finally, that model gets deployed. You are monitoring this at the end of the deployment as to its consumption, and probably repeating the cycle if your matrices and monitorings are not up to the mark, or there are more data that needs to be included as a part of it. Moving on to the next slide, we will see that AWS provides a comprehensive set of tools for your end-to-end machine learning generative AI journey. So you have a lot of services that can store your data sets in. You have services like Amazon Aurora or Amazon Dynamo if you're looking for a SQL or a NoSQL databases per se. If you're looking for a vector databases to support your retrieval augmented generation workflows, you can look at services like Amazon OpenSearch. For orchestrating, you can also look at services like Amazon Managed Workflow of Apache Airflow, our Managed Apache Airflow instance for running Airflow at scale. You can also look at AWS step functions that helps you create serverless orchestration services to orchestrate your own data. And finally, on the act part, we have machine learning specific services like Amazon SageMaker or generative AI specific services like Amazon Bedrock. For your data catalog and governance, you can look at services like AWS Lake Formation or AWS Data Zone that can walk you through, ensure your governance needs are met across this end-to-end lifecycle. With that, I will also like to ask Stephen to talk about a few AI and Airflow examples that you might have seen, Stephen.
Yes, happy to do that, and maybe to drill down into some of those examples that you've mentioned of the types of applications people build, RAG, fine-tuning, and so on. And then I'll also ask David to talk about some of the use cases that he's been working on specifically and some of the challenges that he's faced, which I think people are going to find very interesting. Let's start off with one of my favorite examples. This is Laurel, a really innovative high-tech company for automation of timekeeping and billing, based here in San Francisco, just a stone's throw from where I am right now. They use AI and machine learning essentially to automate the process of identifying what lawyers, accountants, other professional services are doing on a sort of pretty much a minute-by-minute basis, so that they can use that for submitting timesheets back to their clients. It's a very tedious process. It's exactly the sort of thing you want machines to be able to learn by observing the work that they're doing and making those predictions. And so they gather huge quantities of data from their clients' desktops, identify against the ground truth of what those users have said that they are doing at a given time, to predict whether they're making a call or on a conference, or they're filling out a spreadsheet or editing a brief, and then enter that into the timesheet and just get the user to verify it, and then create this feedback loop that allows them to keep their models updated. It's very, very important for them to keep those models fresh as business conditions change, as projects change from day to day, from client to client. So it's not just that MLOps is key to their business, it is their business. And they've grown from using Airflow as the central component for their data engineering workflows out to managing all of their models in operational mode, all the way then through to using now large language models for providing billing summaries. Laurel is really a great case of how you can actually use Airflow hosted on our cloud service, Astro. You can use Airflow really to cover the entire end-to-end process of managing, building, training, monitoring models, both traditional models and large language models. So they use Airflow through Astro for, of course, all of their data preparation, all the ingest of that data from those user desktops, massive quantities of data from hundreds, thousands of different data sources. They actually then train the models using Astro as the way to orchestrate the pipelines of data from the ingest through to the training of the models, and running the compute on Astro, orchestrating the work through to a Kubernetes cluster. The model versioning is then done natively within Airflow, just storing the model out into a model registry that they've created themselves and tied back to GitHub and to the Airflow pipeline, so that you know exactly which model making which prediction was produced by which version of the code, going back to which version of the data. That concept of lineage is absolutely key to Airflow. It's built now into the foundations of Airflow through our integration with OpenLineage. And it really enables them to have a robust and compliant set of model pipelines that they're using to feed their models' predictions through to the clients. They then monitor those predictions also with Airflow pipelines, and then use that to make sure that they can detect model drift and then kick off new model training almost on a daily basis as they keep their models fresh. And as I said, they've now expanded into using large language models. The models for classifying the user actions are actually traditional machine learning built within the Airflow framework, but providing the summaries at the end, the billing summary of the daily activities, is very much something that can summarize, that needs to summarize the actions into a single paragraph of text for submission to the client. It's the perfect thing for a large language model to do. So using large language models and beginning to use fine-tuning of those models to make sure that they reflect their specific business conditions is something that Laurel is also handling with Airflow as the orchestrator. It gives them then this mechanism for managing those models lights out, but also doing the model experimentation, being able to switch out new model forms in GitHub and have those automatically reflected in their Airflow pipelines. And then running that on Astro as the managed service for Airflow makes it scalable, super reliable, of course, very important when it's really running their business, and, as I mentioned before, auditable and compliant because you have complete transparency of those pipelines. Another example that I'd like to mention, also based here in San Francisco, another innovative company that is entirely powered by the use of AI and large language models, is essentially a sort of an automated an automated software engineering teammate that lives within your GitHub repository and allows you more efficiently to manage the incoming flow of issues and enhancements and requests, triaging those, routing those to the right person, even providing feedback back to the submitter, back to the person who issued the bug or the request or PR. In some cases, even suggesting changes to the code that can be checked directly back into the repo. This is now installed on 6,000 more repositories, used by a very large community of users who are actively engaged now with the Dosu bot, providing them with feedback, and used by teams from LangChain and Twilio. And we actually use this for management of some of our open source projects here at Astronomer. And so we can vouch for just how powerful this thing. And all of this, the ingestion of the data from the various repos and from other sources of information, and then the management of those models is, as you might expect, managed through pipelines in Airflow. And so they ingest from these various different sources. They extract that out to vector databases, and, as I was mentioning before, gather analytics about how those have been received by the end users, by the engineers who are both managing and using those GitHub repos. And this is used for, as I mentioned, large open source projects as well as commercial projects by Dosu, really running all of their data pipelines within this framework to allow them to keep their models up to date and to monitor them in production. So that's a few examples that we've observed. And we've also, as Parnab mentioned, just witnessed this flowering of large language model applications being built with Airflow as the, well, if you'll excuse the pun, the bedrock of those applications, feeding them with data, keeping the models fresh, and monitoring them real time. And nobody knows this better than David Shu, our machine learning engineer, who's been building some of these applications himself for applications here at Astronomer. So I want to hand over to David to talk a little bit about what he's been doing and some of the challenges he's faced.
Well, thank you, Stephen, for going over some of our customers' products and how they use Airflow and AI in their use cases. And I'm not just going to go a little bit deeper on how we use LLMs and Gen AI in general and how we apply that to Airflow and our Astronomer's products. The first one is Astronomer Log Summarizer. As many of people who know Airflow, their Airflow logs can be very long and tedious to look through. Whenever your data pipelines fail, which could happen all the time, you have to look through hundreds of lines of error logs, and sometimes with thousands and thousands of keywords. The errors could be missing somewhere in between or hidden somewhere between the warnings, or it could be just lines are too long for you to scroll through. So we decided to build this log summarizer, which helps the user to immediately get a good sense of what went wrong. For an example will be like if you have an error that popped up with your data pipelines or a DAG run, we summarize it to a very concise 1 to 3 sentences in very casual and laid back wording, so that you immediately figure out, oh, here's what went wrong and here's how you should fix it. Instead of going through, like, it could be ranging from a minute to a few minutes to 10 minutes or 20 minutes of time to figure out what exactly could have happened. So to build this product, we fine-tuned an open source LLM, in this case specifically Mistral, the 7 billion parameter model, with a mix of our own data set and some synthetic data set, so that we get the model to output the wording in a very specific wording we want in very concise language, and also teaching the model not just be able to summarize a general passage into some sentences, which most LLMs are capable of doing already. We wanted to be specifically become an expert at looking at Airflow error logs and also be able to summarize that in the wording and tone that we want. So we did our initial fine tuning, but what Airflow comes into play here is that we also decided to incorporate user feedbacks. So whenever we generate an error log summary, users can rate the feedback with a thumbs up or thumbs down, which we would then take that into account and then put it into our database and run our iterative fine-tuning on a monthly basis to continue to improve our LLM's capabilities in terms of summarizing and just moving away from potential noise or errors generated. That could be something that's happening on a monthly basis, or depending on how much data we get, we could be running it more frequently. And as one would imagine, Airflow would be a great case here because it's very natural for Airflow to be built for scheduled runs. And we also have a lot of data processing steps when we get our user feedback and then transfer them into data sets that can be used to train LLMs, and also the LLM training itself, and also even the model deployment, storage, and etc. can all be broken down into Airflow tasks, which are easily managed by Airflow and along with its great features. And let's dive into the next product we have, which is also this one is also related to Airflow. It's called Ask Astro, which is a free and open source actually a tool that we have for people to ask questions about either Airflow or Astronomer products. It usually serves as sort of a first line of defense when it comes to customers asking some very basic questions about the platform or about some of our features and products offered. It's very classic retrieval augmented generation system, which has been mentioned previously in this webinar. We can go into the system design here a little bit in this slide. So on the top is a very, on the top and the bottom, the top we have a retrieval chain, which is for question answering. And at the bottom is where Airflow plays a major part of like handling the data ingest. So for most retrieval augmented generation applications, people use it so that the LLMs is supplied with the most up-to-date, most real-time and factual information. So the LLM may not have knowledge about the most up-to-date information that your company has, and so they supply these information from a vector DB, and then the LLM so is able to answer the user's questions based off of that. But a lot of practices commonly seen in the industry was RAG is that people do this one-time data ingest through some manually written data scripts. Then they put their data into vector DB from potentially corpus of PDFs, websites, and etc., but then not able to easily update their information afterwards. So the key here for Airflow, the key role that Airflow plays here is that we're able to run a weekly ingest from all these data sources. You can imagine Airflow or many of the Airflows like API or operators and everything that Airflow integrates with, or it could be GitHub issues or forum questions and answers or Stack Overflow pages, that all these things have new information coming in all the time. So imagine a function name got changed, some new features got added, and the user wants to ask questions about them. So Airflow plays a key role here in making sure our knowledge base and our data in our vector DB is always up to date. So it's always able to supply a user with the most factual information. And then with these two products that we have, and along with some of the use cases that Steven mentioned, we see some very common patterns that relates to AI in prod, and also relates to how Airflow can potentially help solve these problems. And so at this slide, we're going to just go over some things at a higher level. You have the data ingestion, experimentation, and observability. So for one big thing about LLMs or even traditional machine learning is that how your model behaves depends so much on what data you're feeding into your model. So Airflow makes the most natural sense in terms of keeping your data up to date. And with Airflow having so many great integrations with things like your vector DB companies or libraries, or it could be service providers, it makes it a very seamless switch if you want to play around with different components and also try out new things. And along with observability, which has a lot of these sounds basic but very fundamental features like retries, dependencies, alerting, and etc. that would be very helpful for your entire end-to-end machine learning lifecycle. And we're going to go a little bit deeper into some of the smaller challenges that's funneled down from the common patterns. So for example, I think I already mentioned keeping data up to date is something that Airflow is already the standards for. And then there are perhaps some slightly more fundamental features like automatic retries. So imagine you're pulling data from GitHub and you're getting rate limited, then you can retry based off of some exponential backhoff. And there's also parts like Airflow being very tool agnostic. You have the taskful API, which helps you really switch between your existing potentially data manipulation script or ML script to very easily integrate it into Airflow. You also have other parts like datasets, dynamic task mapping, which solves your pipeline complexity problem. And you may not see this as much of a challenge when you're writing a small data pipeline, but once you get into a bigger data pipeline where you have multiple steps of data parsing, could be, for example, in the RAG pipeline, you're parsing your documents and you're chunking it afterwards. They can be broken down into many tasks. And then that's where things like branching, and then depending on your data that's being outputted by your previous task, you may want to schedule multiple tasks afterwards and that kind of things. So that's where all these features with pipeline structures come into play. And then I think slightly mentioned before, we have parts related to scalability and also observability. It's very important to be able to trace your metadata throughout your entire lifecycle in your entire data pipeline. And basically being able to know which model is associated with what data, and then also being able to easily switch out your compute when you need to scale your data pipelines. And the most important part is reliability, of course. Hundreds and thousands of companies use Airflow in the real world environment. And a lot of them even, for example, use Astro, which has a great SLA guarantee, so that they're guaranteed a very high availability. And this is something that takes the heavy lifting off your shoulders. And then just to wrap up everything, I think there are a lot of challenges, and with all the use cases that we have involving Gen AI and AI ML use cases, Airflow really is a great foundation to get started in terms of building your whole lifecycle and as well as your data pipelines. You have all these features that I mentioned, from could be something very, very fundamental or sounds slightly more basic, could be like the taskful API, automatic retries, branching or deferrable operators, but it could also be something like helping you build more complex DAGs and data pipelines, such as like scheduling your DAG runs with data sets and having dynamic task mapping. And then there could be things more related to error handling observability, right? Such as like error notifications, set up and tear down tasks, or if your data needs some backfilling or reruns, that could also be a great use case for Airflow. So yeah, and Airflow would be a very important tool for your data pipelines, and it could really make a huge difference to differentiate yourself from your competitors.
Great. Thank you so much, David. That was fascinating. Thanks for talking through a little bit about your work with Airflow and generative AI and the applications that you've built. I think if folks want to interact with you directly around that, I recommend actually going onto the Apache Airflow Slack instance, where there's a channel where you can actually directly interact with the Astronomer team. And within that, you actually can ask questions from the Ask Astro chatbot. And if you have feedback on that, you can talk directly to the team who built it, both about the answers that it gives, as well as how it was built and how we use Airflow. Aside from that, I also encourage you to go to our respective websites for AWS and for Astronomer, where we have plenty of content about building applications with generative AI and machine learning applications and the use of Airflow within those. And you can also sign up for trial versions of Airflow if you want to give it a try. And so, Brian, do we have questions?
We do. So a few questions over here in the chat. First off, let me bring all of you guys back to the screen so we can all answer these. So Alex wants to know how many samples are required to train an LLM.
David, do you want to have a
sure.
stab at that?
I like how we're looking at each other to see who's answering.
I think the answer is a lot.
I think this question is a good question, but it really depends on your use case, right? For example, if you're a lot of people fine tune for a specific styling or a specific wording of your output, then it's less so about new knowledge introduction, which means that smaller samples are okay. Like I would still start with 1,000, but and then maybe 1,000 to 5,000 is a good ballpark to get started with fine tuning. But if you're introducing like large amounts of new knowledge, for example, things like you just introduced or invented a new SQL like language and you wanted to learn from the scratch, that may be something that requires a lot of samples for, because you can imagine the model needs to have seen enough samples to be able to generalize that knowledge in production environment. So it really depending on your use case. And what I also found is that sometimes the model itself already has some decent understanding of whatever you're trying to do. Then in that case, perhaps just get started with a smaller sample first, and then see how the model performs, and then continue afterwards.
Great. The next question: what is the best way to validate model input, model output? How many samples do you need to validate to feel comfortable the model is generating the appropriate output?
That's a really great question. I think, especially for generative AI, measuring quality and assessing model output is a really challenging thing. David, let me turn to you again, because I know that's something you've had to think about, and then Parnab, maybe you can back him up.
Sure.
Yeah. So sure, yeah. I think you can do some very basic evaluation. So let's take Gen AI like LLM as an example. One problem you'll commonly run into is that, let's say your ground truth label, say your question is, what is airflow? And your answer could be really worded in so many different ways. And you could have, when you're training or prompting, or like, I guess, fine tuning your LLM, you could have a ground truth such that it's worded in one way, but it may not be the perfect answer, right? Sometimes you even find the LLM, it deviates from how you worded it originally, but it's actually a better wording. So to measure directly use any quantitative measure may not be necessarily the best metric. I think you should use quantitative metric as a first line of defense, maybe do some thresholding so that you only use it as something that you're using for a comparison, but not necessarily the absolute one thing fits all sort of thing. I think ideally in production, what you see is that a lot of times you want to compare head to head. For example, you have the original model and you have the new model, and then you based on human feedback, like here is the same question that's being asked, and which one does the human prefer between the old model and new model? And then eventually you see a preference between model A and B, which one is being favored more, and that's when you start to realize one model is better than the other. And that's the general gist that I've seen. But maybe Parnab has more to add.
Yes. So a couple of things. I like what you said. So I think, David, you called out two things: human in the loop kind of feedback, human in the loop kind of evaluation, and as well as be cognizant of the non-deterministic nature of model outputs. We have also seen our users on AWS. We also have a model evaluation platform within one of our services too. And the way we do this is kind of create variations of the answers that are possible. So you kind of give it a probable answer and then see how close is the generative model best matches that. So there are some techniques to go do that. If you're interested, again, I am also available on the Slack channel for the open source Apache Airflow community. Hit me up, Slack me, ping me, and we can talk about more. But I completely agree with what David said with the techniques and processes there.
Great points. Mandula had another question. If you have to choose between RAG versus fine tuning, what are some things you should consider?
I can take that because I've been probably, even today, I had a customer call on the same topic. There are a bit of nuance there. So if you look at fine tuning, It helps adopt a general large language model to perform well on specific sets of tasks, making it more task specific. Okay, so we had this customer wherein they are taking their existing data set, created a fine-tuned model which can go answer specific sets of questions on, let's say, medical science and medical intelligence that they have already data on. Okay, and they need more nuanced set of output out of those large language models. On the other hand, retrieval augmented generation focuses on connecting the LLMs to your own knowledge sources and uses a retrieval mechanisms. So what it does, it's essentially combines the generative AI capabilities along with the search and incorporate that relevant information from that knowledge base itself. So the first part of RAGs is let's go search against your knowledge base to find out some relevant answers, semantic searches, etc., and then use that to tune your answers using retrieval algorithm or using large language model capabilities. So I see them being complementary used, etc. So most of our customers start with a RAG kind of an approach to see if that meets their needs. If they some of the needs might be met, some of the needs might require more fine-tuned model, in which case they go ahead and create a more fine-tuned model using their own sets of data to get a more task-specific answers there. David, what have you experienced in your interactions with your customers on this topic?
Oh yeah, yeah. Thank you for passing this back to me. I think yeah, mostly like what you said is correct, and I was also thinking that it depends sometimes on what you're trying to achieve. I think RAG you see a lot more was a lot more beneficial. Like for example, the use case I mentioned, the Ask Astro chatbot, which is like you want like very factual, like up to date information. You want to refresh it very often. Then it makes sense to do RAG. Whereas like frequent fine tuning is costly anyway, and especially if you're depending on your use case. If you just want to introduce small bits of information in a very quick fashion and doing it very repeatedly, then probably RAG is better. And then also the slight problem with fine tuning is it's still a black box, meaning that you don't actually know how well it's going to recall or generalize to your training data. Whereas RAG, it's much easier to ground it very factually and making sure it doesn't hallucinate. I think fine tuning, if you want very specific factual information that gets recalled, then you need a lot of fine tuning data for that to make sure it kind of embeds into its memory very deeply. Yeah.
Great points. Phil wants to know any recommendations for data pipelining near real time using Astronomer or Apache Airflow.
Yeah, that's an interesting question. I think historically, I think Airflow has been focused more on batch processing, but we've certainly seen cases that I would sort of say, well, you actually use the phrase yourself, near real time or sort of micro batches, and that's quite common. There's a food delivery company in the UK that uses Airflow to make product recommendations, and as you can imagine, those need to be fresh, so to speak, and the way that they do that is by regularly training models, maybe on a daily, weekly basis, but then having small batches of user input come in and then scoring those and feeding those back into the application database. So I think certainly there are plenty of examples where we've seen Airflow being used for that sort of micro batch approach.
Great. And I think there's one more question here. A quick one, Alex wanted to know if someone could post the Slack channel. Was there a Slack channel mentioned? And then we had a question from Alex as well. Can you speak more about model experimentation? How do you automate validation and drift?
Who wants to take it? I can take it too. Yeah, so I talked about model experimentation a bit in the slide. Okay, so there are a couple of things that you should, when you start off, okay, which models to choose, understand what you need to do. Is it a text generation model that you're trying to look at? Is it a image generation model that you're going to look at? Then do some kind of research into the available models and what is your threshold that you want to go. How much do you want to go spend on experimentation, as infrastructure costs would be another important factor. So what are the inputs and output capabilities of models that might be also useful. So once you have those parameters defined, there are multiple ways to go experiment on or find a bucket or a list of models in there. Then what you can do is start with a generalized prompt that might work, many or variations of those generalized prompt particular to each of those models, and then maybe create an Apache Airflow pipeline which can do this at scale. For one prompt, run this through a set of models in parallel, generate the outputs, store them, and probably have a human evaluator or some kind of other evaluators look at those and rank them in certain order, one on a scale, maybe on a scale of 1 to 5 or 1 to 10, whatever your needs might be. And then as you iterate, you can pull in more models, change the prompts on those models on the same horizontal lines. So I see the model experimentation and the prompt experimentation with two verticals of the X and Y axis, and you are probably looking at the highest point out there to be able to understand which models makes the most sense and for the current version of it. But again, as every day I see new models coming up, either open source or closed source through many of our vendors. So your existing playground should have capacity to include new models, new prompts, and be able to iterate on your data sets there.
Great, thanks, Pranav. I think that's just about all the time and all the questions that we have. So thank you guys. This has been incredibly enlightening. Really excellent presentation and excellent overview of the capabilities of Airflow and Astronomer. So thank you very much for joining us today. Great insights from our speakers. If you missed any of the webinar or want to rewatch anything, the recording will be available at the same link if you just refresh this page after the conclusion of this webinar. We thank you again for joining us, and many thanks to our partners in Astronomer for making this webinar possible. Have a great day.